So we've spoken about how to get the inputs into your circuit, but we also need to understand how to get the outputs from your circuit. And here's the LED that we're going to be using to do that. We used the LED last time in lab, but it was a very non-traditional use of the LED, so I wanted to briefly talk to you about the more traditional way that we're going to tend to use the LED. Now we're going to take the LED and we're going to plug it into the board, but it's important to remember that the LED is a polarized component. This means that the two leads are not symmetric. We have to make sure that the correct lead goes to positive and the correct lead goes to negative. Now here you can see that the two leads are actually of different lengths. And this is very helpful to us because the longer lead is going to be the one that needs to be more positive, and the shorter lead is going to be the one that needs to be more negative. And for our purposes, we're going to attach it onto our breadboard using a 180 ohm resistor right here. And as you'll read in the lab handout, the purpose of the 180 ohm resistor is to limit the amount of current that goes through the LED. The LED needs to have about 1.8 volts and about 20 milliamps of current flowing through it. And if it has that, then it will show very bright light. But if it has more than that amount of current, significantly more, then it will burn up the LED, and you don't want that to happen. So the purpose of this resistor is to absorb the rest of the amount of voltage, because we know that the digital logic devices are going to be generating about 5 volts. That's much more than the 1.8 volts that the LED needs. So what I'm going to do is I'm going to take the longer lead. So you can, again, remember that the two leads are of different lengths. The longer lead needs to be more positive, and for our purposes, that means further away from us, because remember, up here it tends to be positive, down here it tends to be ground. So I'm going to plug it in such that the longer lead is further away from me. Now that it's plugged in, it's hard for you to see that they're different lengths, but they are. And so I have the more positive lead further away, the more negative lead closer. If you look in very closely, you can see that one of the two sides is also flat. And that side is the more negative side, but I don't know that that's very helpful as compared to the lengths of the leads. I always just look at the leads. So now what I'm going to do is I'm going to take the output of the switch, remember, between the switch and the resistor is where you connect it, and then I'm going to connect it up here to the LED, and by doing that, what happens is I'm going to take the signal, it's going to pass through this wire, and then the current's going to go through the LED, and the current's going to go through the resistor, and then that's going to go to ground, and that's going to complete the circuit. So if I've done this correctly, then when I flip this switch on, the LED should light up. And when I flip the switch down, the LED should turn off. So I can flip the LED on and off all day long. And of course, this is interesting, I suppose, but what we're going to do in lab is we're going to have digital logic gates in between here. So the inputs will go to the digital logic gates, and then the outputs will go into the LED. That will allow you to see how different combinations of the inputs yield a particular value of the output.